Hello everyone, my name is Vedika and today I have developed a machine learning project titled as Breast Cancer Risk Prediction App. It is built using a support vector machine model and deployed through a user-friendly interface using Streamlit. The goal is to provide a simple tool for classifying whether a tumor is likely to be benign or malignant based on diagnostic measurements. Breast cancer is one of the most common cancers affecting women globally. Early diagnosis significantly improves survival chances. In this project, I have used the popular breast cancer Winscoin dataset, which is globally exclusively available on Kaggle. It includes a 30 real valued diagnostic features manipulated in such a way that they are measured from fine needle aspirate images of breast mass samples, basically a mammography report. The entire data set includes attributes like radius, texture, concativity, area, and smoothness across mean, standard error, and worst case values. Initially, 30 features were present. However, through all the correlation based filtering, I removed 8 redundant features, which were like very correlated with area. So, which was all done under data pre-processing. It left me with 22 features, which were used to train the model for better generalization to achieve less overfitting. The model I used, basically I tried out all kinds of algorithm like decision tree, knn, regression, etc., but to gain maximum accuracy throughout the entire program, I used a support vector machine model and the probability was set at true, which allowed us to compute prediction probabilities entirely. And the data set was split into training and testing data set. The SVM was particularly trained on the 22 selected features and evaluated for accuracy, precision, and recall. After the entire training was done on the model, I had to serialize the entire model using Python's pickle library, and then I saved the PKL file. To make the model more interactive, I had used the Streamlit web application. It is basically a front end which allows you to input all the 22 diagnostic features that the model is entirely trained on through number sliders. And I had also included the reference ranges. The reference ranges will give the user an idea of what you would like to see in the blur report to help users basically understand the realistic input values. For the visual interface, I added a themed like header image with breast cancer awareness ribbon to reflect the seriousness and the entire intent of the tool. The UI that I have used here is also a two-column layout to make the input process cleaner and more impactful. Once all the values are entered in this particular input front end, the predict button will trigger the model, and there will be either two outputs. One will be either benign or another one will be malignant. Benign will indicate low risk cancerous tumors, and malignant will indicate high risk of breast cancer, basically needing immediate medical attention. The app is very robust and it takes care where the model or image fails to load, and it will just give us the error message if anything inside the model is not working out for the given values. The app is, of course, deployment ready. You can also find it on my GitHub. It is very lightweight and fully deployable on any kind of platforms like Streamlit, Cloud, or Hugging Face Spaces, anywhere. The entire summary is available on my GitHub account. So basically, to conclude with or to summarize, this is like a practical educational machine learning project which applies real world healthcare data to a predictive web interface. I hope this app contributes in some small way to broader goal of accessible diagnostic tools. Thank you for watching.